Recursion, recursion, sing about. Oh, hey, sorry, I was just singing the super fun recursion song. Hi again, it is Mr. Ensimer here with another video. We are doing recursion this week, so I'm going to give you yet another example. The primary examples, of course, the ones we did in class, the factorial and Fibonacci. Those are just kind of considered the famous, very common recursion problems, but there are others, and so I want to expose you to some of those. This is, as I probably have said in class at this point, one of those topics that's just kind of over a lot of people's heads at first. But I promise you, if you stick with it, do some examples, it'll start to make some sense. So for this program, what I'm going to do is count the number of stars in a typical triangle. Something like this. If I have this triangle here, we'll say that that has 4 rows, and so when you count 1 plus 2 plus 3 plus 4, or 4 plus 3 plus 2 plus 1, because addition is both commutative and associative, you can go back and forth. The total is 1, 2, 3, 4, you get 1, 2, 3, 4, 5, 6, you get 10. So we're looking for 10. So I'm going to do this both without recursion and with recursion. So if I'm going to do this, we won't even do it with a function yet. Let me do what we have done, where I say go from v, v goes from 1 to 4, v plus plus. And then h goes from 1 up to v, h plus plus. C out a single star, C out and L. Click my little triangle, like Inception, click a triangle to make a triangle, and boom, there we go. Now, this didn't give us 10. What we need to do is also incorporate a variable, count equals 0, and then every time we make a triangle, I'll say count plus plus, and down at the bottom, I will say C out, count. And so, again, Inception time, click the triangle, make a triangle, but also now gives the total, we get 10. So, that is the non-recursive way. There's no function involved. It's just iterative. Iterative meaning we did it with for loops. When you do recursion, you don't have the loops. The recursion is the loop. You're calling a function inside of itself. And so, let me do this exact same thing now. Using recursion. So if I say int, let's say count star steps or something like that. I'm so good at naming things. Send in the number of rows, give me the total. So the parameters, the input is the number of rows, so in this case it'd be 4, and the output should be 10. So if I come down here and I say I'm going to see out count star steps of 4, it should give me 10 as well. Int count star steps, send in, let's go row. Alright, so when you do this, with recursion, again, there's no loop involved. The recursion is the loop. There's 2 cases. There is the recursive case and there is the base case. So you have to sort of break it down into those 2 cases. We did the factorial. You know, if you're watching this after we did the factorial, which hopefully you are, this will make a lot more sense if that's the case. The base case of the factorial, it's when it stops. When you get down to 1, you know, 1 factorial is 1. You just get the number itself. And so in this case, when you have 1 single star, when you have the first row, you have 1. So that's going to be my base case. So is when my row gets to 1, stop, return 1. What about the other ones? Well, you know, if I go back up to my picture here, on row 4, I have 4 stars. On row 3, I have 3 stars. And the idea behind recursion is it builds up from the base. Meaning, if I have this triangle, there's 10 stars. So the answer to if I have 5 would be I have 5 more stars plus what came before, 10. So now I have 15. If I did the next one, it'd be 6 plus the number in 5. But the number in 5 is 5 plus the number in 4. The number in 4 is 4 plus the number in 3, and that's how this works. So as I code this, what I'll do is I'll say if the rows is still at this point above 1, I'm going to return the number of rows plus call the function again, but send in one previous. So again, put in numbers there. Right now we have 4. So 4, a triangle of size 4, is equal to the 4th row plus the triangle that has 3 rows. And then when you get to 3, the triangle that has 3 rows is 3 plus the triangle that has 2. And so we just keep working that down, and we say else return 1. It's one of those things where it's like, when you see the final answer, it's usually so simplistic, but developing that can be a struggle. Figuring out, like, what do you mean by base case, recursive case? So you always have to think of it as building blocks. Like, how can you model something with the shape that it is now, and then add one more thing, or take away one thing, and then what does it look like? So if I run this now, I should get 10. And there's my result. So, stare at that, put in numbers in your head, think about what you're saying. Again, I put in 4. So when I put in 4, is 4 above 1? Certainly is. So I go and I say the answer is 4 plus a triangle of size 3. And then it does this again. And then you send in 3. Is 3 above 1? It certainly is. So in memory, you still have 4 plus, but now it is 3 above 1? Sure. So 3 plus triangle size 2. Send in 2. 2 is 2 plus the triangle size 1. 1. Oops. There's our base case. So we return 1. So the answer is, it unwinds itself. 4 plus 3 plus 2 plus 1 equals 10. That's recursion. Awkward silence. More awkward silence. Wrap your head around it. We'll do a couple more examples. Until then,